from space and videos from space. So they have many of the same missions that we have. I'm going to show you two pictures that illustrate some of the visions for the future that they articulated to us. One of them was a future Chinese space station, in which they talked about having it assembled in the early parts of the 2020s, looking very much as the modular type of station of the International Space Station. And the other was a mural in their training center with a vision of where the Chinese might like to go with human spaceflight. And of course, those are Chinese astronauts walking towards a Chinese flag. I had a discussion at a separate visit to Beijing with a pharmaceutical CEO there. And the day that I landed, the headline in the China Today newspaper was, "China goes to the moon." And so I asked her, I said, why, what are you sending to the moon and why are you going to the moon? And that was before they sent their Jade Rabbit, the little explorer, a rover that they sent to the moon. And they gave me three answers that were very reminiscent for why many of us, I think, explore. We want to inspire our youth. We want to organize our industry. And we want to be part of the world stage in human spaceflight. So while we don't have any Chinese representatives here to talk in person about their current plans or future plans, China has been involved with France for many years in research, and they are now. And so today we're going to have some speakers that will talk about a broad view of that, about a government relationship view of that, and about a particular research project for that. I'd like to extend my thanks to Philippe Dronneau of the Cité de l'Espace, who helped us put this program together, and my three speakers that you'll hear from in a moment. So we're going to hear from Isabelle Sorbet-Berger. She's a historian and writer and a policymaker, especially a policy reporter in the academic environment, particularly of Chinese space. She is an academician as well. You'll hear from Pascal Ultra-Gerard, who is the Deputy Director of CNES for International Relationships. And you'll hear from Philippe Lier, Orbital Systems of CNES, on an experiment called the CardioSpace Scientific Project. So with that, I'd like to invite to the podium Isabelle Sorbet-Berger. Dr. Berger. And I think we got you all there.
Bonjour. Alors, je suis un petit peu impressionnée de devoir intervenir dans le cadre de ces journées sur l'exploration de l'espace, puisque, comme on vient de vous le dire, moi je suis un académique, j'ai, on va dire, les pieds sur terre, d'autant plus que ce que j'étudie, c'est la manière dont on occupe l'espace, c'est la façon dont différentes puissances spatiales, dont la Chine,
how the various space powers, including China, how they are taking possession of the near suburbs of Earth and how they participate in various activities. And amongst these activities, the one we're particularly interested in, and is most important, is the manned space, the inhabited space. Very few space powers made the decision to be autonomous there. Here in Toulouse, for France and Europe, the choice was different. We chose to cooperate. And I think it's a very interesting and very rich choice, because we fly with the Russians, we fly with Americans. I say we, I'm not really concerned, but it's a way of making this ours, because we all project into the extraordinary world of those who were able to fly to space. and who benefited from this space vision of our planet. I'm also involved into space geography, and on this map I wanted to give an image of the capacities of the various countries as of today, and I chose to focus on the role of manned space, the presence of man in space, where you can notice that we have three major countries who can have control on all these activities. Of course, Russia, United States, they are leaders today for the International Space Station, and the Chinese with their own program you just heard about, and their ambition in terms of orbiting space station and their projects for the moon, which were quite interesting. And if we cannot benefit from the presence of Yan Yiwei, it's also because space in China is integral part of the Chinese dream. It's the motto of President Xi Jinping. Tomorrow, the next Congress of the Chinese Communist Party will start. It will politically be a very important day, as they will confirm the present choices made by Xi Jinping, and we will see what will happen after his succession. And some cosmonauts have been elected as collective representatives, but they are a very strong symbol, a physical symbol of this famous Chinese dream. Before we switch to the next slide, I don't know if it's very visible. After that, we can hierarchize. We can set some kind of an order. Some countries are not involved in manned activities. In blue, you have capacity to send probes and explore the solar system. And I think this is a major project. China is getting significant success there, but they were indeed quite late when compared to Europe, for instance. And the Chinese dream, as I said, I think copied two extracts of the White Book for those who are interested. There is a White Book published every 5 years in China. The last one was published in 2016, and I think these two sentences are really illustrating the strong integration of space as a place for high technology. In India, as in China, there is a common speech shared by the politicians, space community, and public opinion too, noting that China and India were really at the spearhead of science and astronomy, and they wanted to find the place they had a few centuries ago, and they wanted to come back in equal terms with the other major space powers, as they are demonstrating great skills and competence in terms of modernism, opening to the future, robotics, and the share between human activities and robotics being a pretty wide debate. And to insist on what we said during the introduction, the official speech for space is to explore, develop space industry, and I think this is interesting, and we should keep that in mind, because Chinese space industry is state-run. There are very few private operators, very few, and we are not sure at all that this private sector will have a share of this. And today, in most specialized publications, you have this comparison between the American space power and the Chinese. There's probably a mistake somewhere, because the development of these two space policies cannot be compared in any way. And something troubles me as an outside observer is that Russia is not speaking out, although they are still a major space country. They are ambitious in redefining the space policy, trying to modernize their industry, but there is no doubt that they are still very strong space country. You've seen that the stakes are different. Exploration, space industry, trying to transform China in a space power. It's a dream. And back to the motto and this keyword that is really well suited to the Chinese program. And we will probably have a very good presentation illustrating that, the adequation of space and the Chinese Communist Party. What's interesting afterwards would be to try and see the context of this logic behind the underlying these space policies. And for China, the logic is to try and be autonomous, the national pride. Why being autonomous? And well, this is an illustration of the various Chinese capabilities in terms of space. And then I'll tell you why we discussed autonomy. So back to our slide. In this presentation, we can see what was said in Copios. We have two sides to it. One, these space successes they had. This thing about Chinese with their own capacities, even though we know that there was some initial cooperation with Russia, but everything was redeveloped in China itself. And next to this independence and autonomy, you have the major question of international cooperation. It's a major stake for China, first because they were left aside, and then because it allows them regional influence on the Asian area, where they are more or less competing with Japan and China, the three space powers having different logics and advertising different skills, and also understand the Chinese ambition to be acknowledged as a full-blown partner for the future missions on Mars and maybe earlier some missions to the Moon. And to put this back into context, we have a general view of this. You have this graph at the top of this slide where you see the various flights since 1961, since Gagarin's flight. On the bottom of the slide, you have the Soviet and Russian flights. You have the various American flights. The longest ones are the stations. You had Skylab with the inhabited part, then the Soviet space stations, and today the ISS. And next to it, you have the small Chinese flights there, and this new Tiangong station. With Chinese, we have a newcomer with clear ambitions, it's noticeable that the 5-year plans have a benefit, which is that the 3 major steps advertised in 2003 are happening. And unlike the Apollo program with Kennedy, who set a very ambitious target in a very restricted time frame, the Chinese program can have some gaps of 1 or 2 years. It's not important. The major thing is to succeed, to do it. The faster we can succeed, the better, but it's not the priority. And you will see further in my presentation, when we discuss the budgets of the space industry, you can see that China did not give a high priority to the manned flights. There's another dimension we forget sometimes. It's still a developing country, and for them, space is key in terms of infrastructure to help for Earth observation, for telecommunication, help the harmonious development of the country. If we continue, there is an older slide, this one. We wanted to show you how things were happening before the year 2000. 1 square is 1 cosmonaut or astronaut. If it's brown, it is Russian. If it's blue, it's American. Green is European. Yellow is mainly Japanese or Asian, but mainly Japanese. What you can see here, and you have the colors there matching the nationality of all the countries who participated, and you see that China never flew. And if China's inhabited flights are so important, it is precisely because for the first time, with their own resources, they filled the huge gap existing between them and the rest of the world. This slide shows us the budgets and the number of orbiting satellites. Each square is 10 satellites orbiting. These figures are for the end of 2016. Of course, you can ask the question of the small satellites, and this will destroy this statistical system, because of course a nano satellite or a micro satellite will not be as significant budget-wise, or when you discuss industrial involvement, cannot be compared to classical satellites as we've known them until now. But if you compare budgets, you have the color codes. This is the relationship, the ratio between budget and GNP. It's interesting to say that countries that are today making the most efforts to have a space budget are, of course, the US. It's over $45 billion, including military and civilian satellites. And the second country is Russia. And if you look at the ratio with the GNP, China is still under. As a geographer, I will say that every time I say GNP, it's a bit of a problem not discussing GNP per inhabitant, and that China is not as comfortable. And this probably explains the limited effort they make on space. And beyond the exploration and prestige, they want to go for useful space. And you have a huge increase of the observation satellites because they need it to develop the country. I'll be waiting for questions, but I can tell you now that we do not know exactly the amount of the Chinese budget for space. We have various ways of trying to assess that. We all more or less agree on an error margin of maybe $1 billion, but they are probably well below what we have in Europe, for instance. And it's also interesting to keep this in mind. What you will observe too, well, you have Russia and China investing comparable amounts. India is probably the smallest space power in terms of budget. It's around $1.2 billion. And Japan, they're, well, somewhere between China and India, but the requirements in terms of geography and development are not the same for Japan as it would be for China and India. What you can note there is that you have various models. The American model, even before privatization, the new stakes, the new El Dorado of the American space industry, you see a huge amount of satellites for a headcount in terms of industrialists. That is rather restricted. It's more or less the same for Europe and Japan. You have another model, it's the Russian model and Chinese model, very, very much alike. This is probably linked to the state industries and some specific approach of trying to cover the whole technology range. India is an interesting case because it's the only country in the world where they have no space industry as such. And the Indians are reconsidering this today, but this is not really what is interesting today. We could discuss this further when you ask your questions. What seems important today is in this context to try to find what will become space cooperation, what will be the place of China and the other countries too. What will be the future of man activities in space? This frame is a summary made by a Japanese colleague, Kazuto Suzuki. I reworked it on myself, and we really converge. We have the same analyzer. You have some different logics you could identify, and they are underlying everywhere. You have the logics of science. It's the geophysics national year. It's not the only one, but it's a major event. You have the technology logics, of course. The space is a media we have to conquer. It's a real challenge for engineers. You have the American logic. They are the first players in space, which is commerce, trade, and then the major stakes underlying these various choices: security, autonomy, infrastructures, helping development, and the issue of financial logics. How much money are you ready to invest in space, and for what ambitions? Here you have the goals as they are perceived by these different drivers. The Frontier Program, the technological excellence, competitiveness, reinforcement of capabilities, improving economic and social life as well. All this held in place by budgetary discipline. This you cannot do without today. And if you could ask some question maybe on the future of this private space belonging to private companies, it will be constraints that will be just as strong as the financial and profitability constraints you will find in private companies. What I wanted to tell you is this, and I will leave the stage to my fellow speakers, and I will be here for questions if you have any.
I'd like to call to the stage Pascal Ultra-Gerard, who is the Deputy Director for CNES for International Relationships.
Good afternoon. Thank you for inviting me and to give me the opportunity to present to you the cooperation in space between France and China. So I will not talk that much about human spaceflight, which is the purpose of the next presentation. But I will give you an overview of what we are doing with China on space activities. So CNES has many cooperations, many partnerships with our national partners, of course, ministries, laboratories, industry, and so on. In Europe, of course, with European Space Agency, for instance, and also with a lot of outside Europe international partners, like NASA, for instance, but also with India and China, including China. So this is international cooperation is in fact in our genes in CNES. So all our projects are done with international partners. So the cooperation with China has started in 1997 with the signature of the Intergovernmental Agreement on Space Activities. And it is clearly written that CNES and CNSA are executing agencies of this intergovernmental agreement. So we have started meetings of the joint committee between France and China in 2000. And we have also started another type of committee, which is called the Strategic Subgroup, in 2004. And we have also a new player in this partnership coming in 2012, which is the China Manned Space Office, which has been added to take into account the cooperation for human space flight. The last meeting of our committees has been held in May this year. It was the 11th meeting of the Joint Committee and the 8th meeting of the Strategic Subgroup. So you can see that we have many rendezvous with our Chinese partners. We have also signed a Memorandum of Understanding on 2 strategic projects, CFOSat, the Chinese-French Ocean Satellite, and the SWAM satellite for astrophysics in 2006. And this is the 2 projects that we are reviewing in the strategic subgroups. We have also signed a new memorandum of understanding on SWAM in 2014, taking into account the progress of the project. And the launch is now scheduled in 2021. And we have also signed a new MOU on the Chinese-French Ocean Satellite in 2015. And the launch is scheduled next year. We have also an agreement, a specific agreement in oceanography, which has been signed in 2010. And it was dedicated to the cooperation on the HY2A mission, which is an oceanography satellite, Chinese satellite, which embark a DORIS instrument on board. The DORIS instrument is helpful for precise orbit determination of this satellite, which include altimetry measurements. So it's very important to have the precise orbit in this kind of mission. And the result of this cooperation is that we have integrated the HY2A altimetry data in the CNES multi-mission tool, which is called Aviso. So it's a very fruitful cooperation, and we have decided recently, in May, to extend this cooperation for all HY2 altimetry satellites. We have also signed a MOU, Memorandum of Understanding, for the development of the CardioSpace in 2012, and this will be the presentation that will be done by my colleague Philippier just after my presentation. And we can notice that CardioSpace has been launched last year. Now let me talk about the two strategic projects that we have with China. The first one is CFOSat. It's an Earth observation satellite, more precisely an oceanography observation satellite. The main objective of this satellite is to observe the ocean surface wind and the wave at global scales. And the instrument which is on board this, the instruments which are on board these satellites are dedicated to measurements of the sea wave spectrum, which we can have. We have an illustration of this sea wave spectrum on the slide, and also the wind and the relationship between the wind surface and the sea state at a global ocean scale. So it's a long-term monitoring of sea surface parameters, and we have, of course, a strong scientific community behind this mission, including scientists of the atmosphere and scientists of the ocean, interested by the interaction between atmosphere and ocean. So we have also secondary objectives of this mission, including land surface monitoring of soil moisture and soil roughness. And it can also give some information observation on polar ice sheets and sea ice. So one objective of this mission is to better understand the climate change drivers and the role of the exchange between atmosphere and ocean in the climate evolution. So you have here the CFOSat schedule. So as I said, we have signed the Memorandum of Understanding in 2006. We have started the development fund, the phase A of the project in 2007. And we have, the CNES has provided and delivered the payload, the SWIM instrument, which is the French instrument on board this mission, dedicated to the waves characterization. We have delivered this payload during the spring. And now we can, you have on the slide an illustration of the integration of this instrument on the platform. And the launch, as I said, is planned summer next week. Cross the finger. Next year, pardon, sorry. Next week, it's not an option. You have here a chart describing the joint organization between France and China on this satellite. We are providing the wave instrument. They are providing the surface wind instrument, scatterometer. And we have shared all the main functionalities of the mission. They are in charge of the platform, and they will also be in charge of the launch of the mission. Now let's talk about the other strategic project that we have with China, which is called SWOM mission. It's an astrophysics mission. It's dedicated to the detection of the gamma ray bursts in the universe. You know, this is a very rapid and very energetic event in the universe. And so the idea of this mission is to characterize this gamma ray burst, characterize their precise positions, the broadband spectral shape of this prompt emission from visible to a million electron volt. And we have also, in doing so, we have several telescopes, several instruments on board this mission, which will also try to identify the afterglows of the detected gamma ray bursts. So this is, again, a mission that is done in cooperation and with a strong participation of the scientific community, either in China and in France, both in China and France. You have here the schedule of the mission. And so we see that the mission is planned for a launch in 2021. And now, for the moment, we are developing the satellite and the instruments. So it's ongoing work, and the platform will be provided by China. So you have, as I said, the platform is provided by China in the organization that we have. Instruments are shared between France and China. And the launch will be the responsibility of China on the Long March rocket. And we are providing in this mission something that is original. We have also a network of ground-based telescope, around, I think, 40 ground-based telescope in order to have a good understanding of what we measure from space and correlation between in situ ground, and space measurements. What are the next steps for the cooperation? So we have now 5 thematic working groups that are in charge to propose new activities. And we have identified 2 specific priorities for the future, which are the lunar and deep space exploration and the climate change. But we have also some working on earth science, space science, and space life science. So they will continue this process to exchange with China and identify new ideas for the cooperation, in particular in the 2 fields of priorities I mentioned before. So our goal is, of course, to continue our existing and successful cooperation activities. So we are, as I said, we cross the finger for the launch of these 2 very interesting missions. We intend to enhance the scientific interactions for future space science missions. We have started also some discussion with the Chinese Academy of Science to increase this cooperation at scientific level. And we will contribute together to multilateral initiatives on climate change, since we all know that to tackle the climate change and to give more data to scientists to better understand the climate evolution, we need a very strong international cooperation, including all partners. China, of course, is a major player in this field and intends to be a major player also in this domain of climate change study. Thank you very much for your attention.
I'd like to introduce Philippe Lear. Again, he is with CNES, Orbital System Sciences, and he'll speak to the CardioSpace Scientific Project.
Thank you. Yes, in English, okay. Okay, it's okay. Good evening. My name is Philippe Lier, and as mentioned before, I am in charge of the scientific project development at CNES here in Toulouse, not far from here. And it's my pleasure, great pleasure, to be here with you. And I will give you a short overview of the CNES ACC cooperation, which is called CardioSpace. Next slide. First of all, what is CardioSpace? CardioSpace, it's a system integrating different medical instruments in order to provide standard cardiovascular parameters, for example, blood pressure, respiratory rate, electrocardiogram, and in addition of that, specific measurement, because in CardioSpace we added a laser Doppler probe in order to measure cutaneous microcirculation and a sonographer for macrocirculation. On the picture here you can see the whole set of probe when they are used by astronaut. And from a scientific point of view, CardioSpace has been designed to study the cardiovascular system adaptation during human spaceflight. We can say there are 2 main objectives. First, to address the issue of cardiovascular deconditioning by focusing on cutaneous microcirculation and macrocirculation, because we know that spacionauts experience cardiovascular deconditioning. And then have, thanks to the sonographer, a view of the remodeling of blood vessels and heart induced by microgravity. So there are these two goals and the set of probe. And what I want to highlight here is that all the probe can be used simultaneously at the same time with the synchronization, so we can address the result of all the different measurements at the same time. Okay. Now, view of the story of CardioSpace, because it's a joint effort of CNES and ICC, but it's a long story. In fact, we can say that the project was born in 2010. The first idea was to perform a cooperation in the frame of the minutes space flight program of Chinese, and a cooperation between French and China that has never been done before. Then the real kickoff, the formal kickoff of the project was given mid-2012 with the signature of a MOU between CNES and ACC. Here you have a picture of this signature. And then we can say that things move very fast, because then we at CNES develop all the system. This has been realized at CNES and with the support of small and medium enterprise not far from Toulouse. And all this equipment have been tested, and we had a lot of discussion with the Chinese partner. Then, in 2016, CardioSpace has been integrated to the Tiangong 2 Space Laboratory. Here you have a view of this module. It is a very huge module. And the CardioSpace, in fact, has been integrated on ground in this space laboratory that has been launched then. It's September 15 in 2016. So this is an important point, because for us, we had to be ready to deliver the CardioSpace equipment for the Tiangong 2 launch. Then, 1 month later, so it was not far, there was a Chengdu 11 expedition, which was launched in October 2016, with 2 spatialnauts on board, Jing Haipeng and Cheng Dong. Here you have their picture of them. I'm sorry that they could not attend the meeting, because it would have been a good opportunity for us to meet them first and to thank them for the work they have been done with CardioSpace. 2 days later, you have an artist view of the docking of the Tiangong 2 station with the Chengdu 11 capsule. It was down in October, mid-October 2016, at an altitude of something like 400 kilometers. Next step is, of course, a very important step, because you can see on this picture that when they arrived in the Tiangong 2 module, the 2 spatialnauts had in front of them the CardioSpace module, which was fixed on the panel of the station, the Tiangong module. So here you have, on this picture, you can see the CardioSpace 2 equipment. And it is obvious for you, but the Chinese spatialnaut reports to the Ministry of Defense, and you can see that they are. You can see both of them here in the module. Then, during 1 month, from mid-October to mid-November 2016, the equipment was used 6 times for a total of a dozen of hours. So it's very short, but it was the first step for us, the first cooperation in this complex area. And now we can see that the CardioSpace mission is completed, as no further manned mission is planned for Tiangong 2. So the CardioSpace will no more be used in Tiangong 2. The story of CardioSpace was concluded in Paris in December 2016 with the post-flight review. Here you have the picture of this post-flight review we held at CNES headquarters. Now, of course, it is not the end of the story of CardioSpace, because CardioSpace, as I mentioned before, was the first step. And now we are working on CardioSpace 2 or CardioSpace NG. And our plan is to use CardioSpace 2 on board the future Chinese space station. But it is not so far from now. So we have we plan to develop a dedicated CardioSpace 2 equipment for this Chinese space station. Our goal, of course, is to continue the cooperation with the Chinese counterpart and to have a better return on investment on CardioSpace, because as mentioned before, it was very short, the use of CardioSpace. And now with the Chinese space station, we can have a much longer use with more subjects, much longer flight duration, because we can imagine that we can use CardioSpace for years instead, CardioSpace 2 for years instead of for 1 month. And of course, a large extension of CardioSpace studies with new scientific protocol and new instruments. We have some important development to perform before, because of course the specification for the implementation of this kind of equipment on board the Chinese space station are not the same as they were for Tiangong 2. So we have to develop a new equipment, and you can see the idea is to have a rack that can be fully embedded in the station before its launch. Now, to conclude my presentation, it's clear that CardioSpace, it's a technical experience, but more than that, it's a cultural experience. The French-Chinese partnership is a long story. Pascal presented you some example of the cooperation in space. It's a long story, and it's sometimes not so easy, because cooperation with the Chinese is not easy, because we have the different culture. They are far from here. We have different language. But, for example, CardioSpace 2 was a great success, and we can be very pleased with the results of this cooperation. Some explanation, but it's always difficult to give precise reasons for that. But there is on both sides a strong motivation to cooperate in this area. Second point is that we learn a lot from each other. Of course, they have different ways to develop space activities. On French side, we have a lot of anticipation, a lot of paper activities. On Chinese side, it's more pragmatism and experience. In fact, they test directly the material and perform less analysis. And what is very important for us is that we have built a mutual long-term relation, we hope, made of mutual trust. And we hope that this will pave the way for long-term cooperation. Well, merci pour votre attention.
So thank you very much, Philippe. So we're going to enter into a question and answer session. And I think what I'll do first is invite the members as well as the audience to ask first. And then we'll go to anything that's coming through Twitter. So thank you very much for your insights and your experiences on working with China as they build up their space program. So I think you've got some mics. Okay, we have a Ulf, is that?
Yep. I have a question related to this gamma burst program. I remember I was a member of a jury that the European Union gave the Descartes Prize to a Dutch-Italian team who also had in mind to look into the afterglow of this gamma ray burst. Is there any contact between you? I think they had a satellite, the Peppo or something like that, to do exactly this kind of research work.
No, I'm not aware of that, but as mentioned by Pascal, the aim of SFOM is an alert system. So they detect a gamma ray, and then they inform all the community that they have through this direct link with the ground that they have detected a gamma ray burst. So all the other satellites then can be informed that a gamma ray burst has been seen, and ground system 2 in order to point to this direction. Probably in this, there are links in terms of science with this other satellite, because they will be able to receive this information in real time. But I cannot say more about that.
Thank you. Any other questions? Yes, young man up front. Yes, the young man in the middle. Do we have a mic for him?
Yes.
No? Oh,
sorry.
Pourquoi, quand vous avez montré la planche,
when you showed us a slide, we've seen that the Russians have less satellites but have more employees than the Americans. Well, the Americans have 10 times more satellites and they have less employees. This is a good question. There are many reasons for that. In Russia, the state companies were employing lots of people. Traditionally, you had over 1 million people working for the space programs at the time of the Soviet Union. It was even cities, closed cities, totally dedicated to the production of maybe a launcher like Soyuz. They had dedicated schools, kolkhozes, and the system was totally closed, autarkic. It is not the case anymore. Russia has grouped the social industries in major holdings, big groups, industrial groups, but lots of people are still working there. The second good reason is that the American industry is highly automated. They have lots of machines, and the general approach, the way they design a product, is totally different. And if today you look at something like SpaceX, you will see that the new launches they produce need very few people. Very few people work on these launches. The question is it cheaper? This is not clear at all. It all depends on the price you pay your employees, of course, but if you look at the Russian system, the budget and everything Russia still produces with a given budget, maybe people are cheaper. But you do not make progress as fast, and you will not have technological leaps as you can have them today. Merci.
Please. Thank you. Thanks, Bonnie. I have a question. I was twice at the Northwestern Polytechnical University in Xi'an, and we tried to start a joint project in the life sciences area to build up in their university a curriculum on human factors, psychology in space, and the like. I tried to do that together with DLR, and I received an unwelcome stop because there's a sort of an embargo. Have you ever experienced something like that in CNES? And if yes, how did you handle that?
No embargo. In fact, we were invited to cooperate with China. So we were invited by our government to cooperate with China. So it's totally a different situation. And in fact, we know that many other space agencies have some difficulties to work with China, but for governmental reasons. So it's not our case. Of course, we take some. We are obliged to take into account ITAR rules and things like that. But except that, the cooperation is a very good one. What is maybe the most difficult thing is to share the same data policy. But as we have seen, if we created some confidence between the partners, we can access to the data. It is the case for HY2 missions, which we really have access to the data, and we can integrate the data in our data system. So it's really a long-term cooperation with as much as possible confidence in the partner. So it's quite okay.
So I have a question. France has been involved in spaceflight medical research for quite some time. You've had bedrest studies and a center, and you have an instrument now on the Chinese space station. Are you able, through any sort of protocol, to share data to understand? Are you sharing data from their astronauts?
From the instruments, you mean? Yes.
Yes, you are.
Yeah, from our instruments, we get the data, of course, but it takes time.
Okay.
Because I think that and one of the difficulties that everything that is provided by Chinese counterpart to us is checked before, checked and rechecked, and and check again.
Okay.
Exactly. What's I think the problem that they don't want to release some data that they don't really understand. So and sometimes they need help to really understand the data. So it's difficult to convince them that we can help them also to understand their own data. But we manage.
Thank you. Any other questions? Do we have any questions from our Twitter, ASC30? Oh, we got one more up here.
Good morning, Michel Tonini. Good afternoon, I would say. I saw a nice picture of Claudie Aigneret with a Chinese astronaut. Do you have a plan to fly Claudie or a non-Chinese astronaut on Tiangong? And my second question is on the newspaper, beginning of the year, they said that the Chinese wanted to go to the moon to find helium-3 and to exploit helium-3 from the moon. Have you any statement about that? Thank you.
For Claudie, no, I don't think so. But it was just to illustrate that we have the same goal, in fact. For moon exploration, I don't know.
I don't know. What I can say is that usually China tries to do what the others are doing or are planning to do. So if some newspaper are speaking about helium-3 on the moon or anything else, of course they will think about it and they will try to do it if it's appears convenient to the situation, if they have money for that, and if it is decided at a political level. And so, for instance, I don't know at the time if they will send or not a man or a woman on the moon, because you have people saying that it could be a great accomplishment because it will put China at the level of the United States, because Russia did never do that. But in the same time, some others are explaining that a robot and robotic missions are more high-tech to some extent. So it's very difficult to know. What we can say is that they have at least 5 years before the decision and the beginning of the program. So it could help to look at the next white paper on space.
Hey, any other questions? We have one over here.
Les questions sur les réseaux sociaux avec le hashtag ASE30.
Questions on the social networks? Are we planning to send a French astronaut on a mission with Chinese astronauts?
L'ESA a l'intention de commencer des discussions avec la Chine, et je pense
wants to start discussions with China, and I think that indeed these discussions should happen, and the result of the outcome of these discussions, I have no idea. I don't have a crystal ball. There are probably some conditions on these possibilities, and as far as I know, the discussions haven't even started yet. But it's something that should happen. I'll go back in time a little bit. If you remember the slide I showed you on the various nationalities who flew on the Soviet missions and then on the space shuttle, we're back to the idea that it's part of the new Space World keywords. The space is a diplomatic tool. And for China, it's very important to show that Europe needs China to fly. To what extent are we ready for this kind of image? We don't know. It's clear, though, that everybody will benefit from international collaboration. So it's an open question. It will be a highly political question. Technically, we could ask what could we do differently than we've already done elsewhere in that type of station. And you have maybe the beginning of a discussion, and the Russian media think it is something that will happen. The Americans are don't seem that convinced on a lunar base or circumventing space station around the moon. And beyond the International Space Station, there might be a possibility, but this is speculation. We could pair some Russian modules with the Chinese, and the Russians are saying that their docking systems are really versatile, and it's true because they are at the source of this technology.
Any other questions? Got one right back there. We'll take this as the last question.
Thank you. So in terms, because you mentioned about space policy, in terms of space policy, I'm not aware if China had ratified the Moon Treaty or the Outer Space Treaty, but is it some conflict of interest between the logic of autonomy and national pride and this international collaboration, in this case with France? Did you have some issues on this?
Of course, national pride is at the beginning of any kind of space policy program in any country, so there is nothing very specific to China. And China is a signatory of the Outer Space Treaty, of course. I don't think it is a signatory of the Moon Treaty, but you know, the USA are not anyway, and even I don't think that any great space powers has signed this treaty. So about cooperation, I don't see any kind of conflict of interest. You show inside the cooperation that you are existing and that you have your own means to do something. So the problem is, are you a junior partner, a senior partner, and what is the kind of cooperation? This is what is important from a political point of view.
Thank you very much. Let's give all of our panelists a round of applause. So we've talked about the need for collaboration and cooperation and sometimes finding middle ground. So I'm going to reply to Alexander Nitsch's comment earlier about on the International Space Station as to whether they say Oberpfaffenhofen or Munich. Well, this is what happens when you get old enough.